I'm Francesco Badraun. I originally did this talk at ISIG Wellington. You should come along, it's pretty fun. It's kind of like a local meetup for security people. They have chapters around New Zealand, like Auckland and Christchurch and Wellington, obviously. So I originally did this talk and it took about 45 minutes and I cut it down, so it might be a bit dynamic. So depending on what happens, I might have a gift for you at the end. Yeah, so my name is Francesco. You can call me Francescon. Thank you, yep, you're good. No, more like Francesco Continuous Assurance. Yeah. Okay, that's as good as it'll get, so you can leave now. Yeah, so I'll just talk roughly about what continuous assurance is. It's a relatively new concept, so I'm pretty sure not a lot of people know about it. I'll explain why I think personally pretty much everyone should be using it, and if you're not, it might kind of give you some reasons to start looking into it. I'll look at the components of continuous assurance, kind of how you can make it more modular and kind of build your own continuous assurance capability. Then I'll talk through my experience at having a first crack of it. Didn't go too smoothly, so I'll give you some of my recommendations and challenges that I found along the way. Yeah, and then I'll just wrap it up at the end. So, real quick, my background, I've been in security for 5 years. I started as a security engineer, so doing things like scripting with Python, working with WAFs, CDN, just looking after the cloud environment of our company. And then I moved into a security specialist position where it's kind of architect-y. And that's where I worked on this project that I'm going to talk about later in the presentation. And then more recently, I've become a consultant at ZX Security. Love you guys. Yeah, and I've worked for continuous assurance for about a year, painfully. It wasn't fully on the technical capability and building it all. A lot of it was kind of more challenges related to the environment I was in versus the actual continuous assurance stuff. So I'll talk more about that, but yeah, I've done it enough to know it's difficult. So it's not a piece of cake. Yeah, just some hobby stuff. I'm a coffee geek. I like programming in Python and doing web stuff. Playing around with music production. I always pull out the digital audio workstation and have a little go playing on some instruments, but I never actually managed to finish a song. So I can't really show you anything, but I also do a bit of gaming, so yeah, Overwatch is my favorite game. I'd nerd out on Overwatch and coffee any day. Yeah, so just a quick overview of what continuous assurance is. Basically, the core issue is misconfigured infrastructure. So misconfigured infrastructure is the #1 cause of cloud data breaches. I know it sounds quite clickbaity, but it's real. It's, I got 2 data sources for that, at least for 2020. It was the #1 cause, at least, of the first vector of an attack chain, in line with, I think, another 19% of compromised credentials. So, that being pretty common, you probably didn't realize that this is also a really common thing. It's also not hard to do. So in this graph, you can kind of see it, I hope. The bottom right box kind of shows that it's really easy to do. It's on the lowest side of the attack, and it's also really prevalent. It's quite common. So that's a bit of an issue. The goals of continuous assurance is to provide automated remediation of insecure infrastructure. So you're not getting an alert and trying to figure out where it is and fix it manually. Hopefully, if you've set it up right, it's done for you, and that provides a bunch of benefits that I'll talk about later. And it also gives you assurance, so really good for the risk and compliance people. It gives you assurance that you have controls, and those controls exist, and its operating effectiveness is X%, and you know what's happening in real time at any point. And it's done through a mix of kind of monitoring stuff and enforcing configurations. So an example of what you'd want to use continuous assurance for is data protection stuff. In AWS, there's this thing called an S3 bucket. It's basically just a really abstracted way of storing data. So you upload files to it and then you retrieve them. And for encryption, for example, there's multiple things you can do for that. You can enable default encryption, and that basically turns on a setting on the bucket, so every time you put an object into the bucket, it's automatically encrypted at rest. And you can enforce TLS, so you can enforce every time you're uploading those objects to the bucket, it's through an encrypted channel. You can enforce things like access control, so make sure the bucket's not public if it's not supposed to be, and just looking at the bucket policy to see if that's good. Another thing you might want to look at is backup of your data. So with S3, you can do this thing called object versioning, so it just stores every object version every time you upload to it. And you can do cross-region replication. And these are all settings within the bucket that you can automatically kind of check for through automation. So these things are really quite easy to look at. It's part of DevSecOps. I'm not going to talk about DevSecOps because I think enough people have. If you haven't heard of it, it's actually quite interesting, and I suggest learning more about it. But basically, this is part of the DevSecOps movement where you want to encourage developers to create secure stuff from the very beginning. So from the very point you deploy infrastructure, it's secure. You're not kind of reviewing stuff after the fact and finding that there's a bunch of vulnerabilities and they need to go back and change it, and it becomes more expensive. The cool thing about this, though, is it also gives you the ongoing maintenance of that infrastructure and the assurance that it's still secure, after updates and changes within the environment. Like I said, it's quite a new concept, so I kind of struggled to find more information about it and kind of more names about it. So one way I've kind of described it is just cloud wrangling. I think it describes my experience personally pretty accurately. Yeah, so why would you want to use continuous assurance? Basically, it's part of a well-managed cloud. It's part of being mature in the cloud. There is this concept in AWS called the shared responsibility model, where the infrastructure, the hardware, the switches, the data transferring between the services are all managed by AWS, but it's your job as a customer to manage how secure that configuration of that infrastructure is. They give you all the tools, but they kind of don't really tell you how to do it succinctly. So it's really easy to go really wrong. And so continuous assurance goes like a really long way towards providing this, secure in the cloud, my responsibility as a customer. It does a pretty good job of that. And it's really good at kind of telling you what you manage, what you maintain. What if you get cyber insurance and they ask you, well, what do you have in your environment? If you don't have something like this, you don't really know. It helps with billing, it helps with compliance reasons, it helps with optimization. Maybe you want to reduce your resources, all that kind of stuff. And it helps with scale, so really important in large companies, but also like very small startups. If you set this up right and you set it up once, it should work throughout the scale of your cloud environment. You shouldn't have to make many modifications. It should just scale with the scale of your environment. When you're a lot smaller, you tend to start doing manual reviews of infrastructure, kind of at pull request time, or just a project team's about to go live and you kind of have a look over it. That works to a certain extent, but as soon as you start getting a lot bigger in a large enterprise, 4,000 employees, that becomes very impractical. Not possible, but very difficult and time-consuming. And so it just supports like innovation at speed. Developers can do these things on their own without having to introduce security as a roadblock. They can kind of just do it on their own, self-service, and it's really useful for everyone. It helps auditing so much. So I'm not actually a risk and compliance kind of person. I personally don't like that type of work. Have immense respect for people who do it, but I just personally don't like it. But if I was in that role, I would definitely want something like this. You've got a bunch of frameworks that you have to comply against for various reasons. ISO 27001, SOC 2, PCI DSS, LMAO, GDPR, LOL, NZSIM, NZISM. Those things are very difficult to kind of keep a record of what you've done to implement controls for that and then prove it. I'll talk more about it in this next section, actually. So manual versus automated. Manual being like the legacy way of doing auditing. As I said, I wasn't in a risk and compliance type role, so I don't know it end to end in depth, but I know enough that I think this is how it works. Basically, an auditor asks you where are your controls, how have you implemented them. So you take a snapshot in time of your cloud environment, you kind of show them what it looks like, kind of what controls have been implemented on those things, and then that's it for the year or for the 2 years. And then they come again the next year, and then suddenly everything's changed and you don't really know what's happened in between. And if you rely on that data again in the future, it's a point in time. Something happened a year ago and you don't know where it's at now. Whereas this is real time. You just check it at any point. It's real time. It's accurate. It's really handy. The manual way of doing it is you provide a small sample. So like say you have 100 S3 buckets and you provide like 5. Those 5 random buckets show good controls, but that doesn't show you an accurate representation of everything because there could be outliers, there could be a huge difference in the rest that you're not checking. Whereas this checks absolutely everything. It's automated. It's looking at everything. It gives you total. It gives you can break it down to categories, all that kind of stuff of like configurations and compliance. And the big thing is it proves controls exist. So with the legacy way of doing it, you kind of have a Word document, or you have some legal document that you've stored somewhere in a Google Drive. You show that to the auditor, and then you kind of show that those controls have been implemented. But there's no kind of overarching process or anything to enforce those controls. You kind of just have to ask your developers to do it. This has a direct correlation to, I have a policy with rules. A resource must look like this, and that, and if it doesn't, this is what happens. And it's super accurate. It's like, that's all you need to look at, right? You need to look at that and then the inventory to see if those controls have actually been effective. So why wouldn't you want to lint configuration templates? Well, I think you should. That's a weird question. The thing about linting configuration templates is it's really good at preventing infrastructure from being deployed in an insecure way from the get-go. But there's this thing called drift, where resources kind of change over time. You deploy once, and then someone adds a tag to it. Someone changes the encryption configuration and doesn't tell anyone. And there's no record of that unless you've set it up. So linting only gives you that point in time before it's deployed, and it's good for that, but again, like it doesn't show you the full picture of what's going on. I'll skip the first bit. The other thing with linting is everyone uses different tools. They use different configuration as code tools, like CloudFormation in AWS, Terraform, Chef, Ansible, whatever people are still using. It's really hard to enforce linting over all of those tools. I'm sure there's tools that work across everything, but it's quite difficult to make sure that everyone's using the same thing. And then you've got different deployment pipelines. So it's very hard to get everyone into a single point where you can kind of control that point, because there's always going to be people who kind of work around those controls. So drift is good. Use it if you can, but I wouldn't rely on it. So the elements of continuous assurance, it's all about kind of monitoring and remediation. So those are the two main components of it, and you can kind of break it down into multiple different modular parts. With monitoring, you have the resource inventory that I talked about. So that's just like a database of all of your resources, every configuration of that resource, if it's compliant against certain frameworks, if it's secure versus certain rules, is it tagged, whatever. All the information is there for you to look at, and you don't have to kind of trawl through the AWS console or do anything like that. You track the changes, so chronic monitoring of changes. I looked at the thesaurus for like ongoing or continuous because I thought that was getting boring. You want to look at every time a resource changes, and you want to track that change. Resource inventory is good, but if you just do it once and kind of let it sit there, again, you're going to work with the drift, and it's not going to be accurate. You want to make sure that all of those changes to resources are recorded in the resource inventory. And you want to detect when non-compliance is detected. So you have a bunch of rules, policies, and if those configurations of the resources don't match what you're expecting, then you want to detect that, alert on it, and act on it. So you want to do something with that data. With remediation, there's kind of two parts to it. You can detect a resource when it's being deployed, and I personally prefer deleting it, because if you kind of just modify it or do something else with it, a developer thinks they've deployed a resource, and then cool, like that's what I was expecting, and then they come back to it a day later and they realize something's happened to it, but they're not quite sure why or what's happened. If you delete it, they know it's deleted instantly, and they can kind of try and figure out why that happened, and that goes on to the next point of notifying owners. Like, you want to tell them when you delete a resource, or when you modify it, or when you detect non-compliance, and how to fix it. You don't just want to say, this isn't encrypted for whatever reason, and leave it at that. You kind of want to make it as easy as possible for these developers to be secure and compliant. The other thing is on modification. So on creation, you can delete it. On modification, like on a pre-deployed resource, you might want to maybe revert a configuration someone's just changed, or modify it to be the accurate configuration that you want. That runs into the same issue where you kind of developers don't realize what might have happened, so you kind of have to be really, really accurate and really good with the notifying of the owners. So on creation, delete it, that's fine. On modification, probably just change it back to what you want. Then this talks about the linting. So there's actually there's a setting in EC2. So EC2 is like the AWS server kind of service in AWS. There's a setting that you can enable in there which kind of enforces every new EC2 instance has to be encrypted. So the EBS volume, the EBS is just like the disk attached to the instance, that enforces the encryption configuration. So this is really good. This isn't technically continuous assurance, but it helps towards that, because if you enable a setting, then it's going to be hard to deploy insecure stuff from the beginning, and then linting, so you just prevent it from happening before being deployed, so you're moving left in the DevSecOps chain, if you know that. So yeah, I'm going to talk a little bit about my experience doing this. To be fair, I kind of did this and didn't really know what I was doing, and then afterwards I kind of retroactively looked on what I'd done and kind of formed this talk. So I kind of created these concepts after the fact, so some of these things didn't quite work out. For context, we were operating in AWS. Yeah, disclaimer. Like I just said, we didn't implement a full solution. Like everything I just talked about, that's not fully working. We did what we could in the time that we had, which MVP, like we just had to get it done. We weren't able to do all the bells and whistles. And yeah, we were in AWS. We had hundreds of accounts. We had hundreds of thousands of resources. So it's a pretty big scale of environment. You can see why we kind of worked on this one project for a year. And we use multiple different services, a lot of data services, a lot of, like data processing services, like machine learning, just data storage instances, like anything that has anything to do with data, we're probably using it. Yeah, so I'll just talk about the kind of stack that we ended up with. We chose this tool called Cloud Custodian, C7N. Basically, it's an open source tool on GitHub made by, I can't remember who, so I'm not going to, yeah, thanks guys, I appreciate it. Basically, we used it for two components of the setup, the monitoring side and the remediation side. We chose to use this for the resource inventory. I'll explain why that was a bad idea later, but basically to kind of get a view of all of our infrastructure, hold it in a database. And then we used it to detect when non-compliance was happening in the environment. So if a configuration was detected that we didn't think was right, or wasn't compliant with a certain policy, this is what we used it for. And with remediation, Cloud Custodian uses compliance as code or policy as code, so you kind of define like a YAML template of, these are the exact things I'm looking for. This is what I want to do if this resource isn't compliant, and this is how I notify owners. And then, yeah, so there's actions in there, so we can delete the resource, we can modify it, we can spawn a sub-process or a Lambda or something to run some other code because of that. So it's kind of all a complete package, which was really cool. For those who know about AWS and know about AWS Config, AWS Config is a compliance and remediation type tool as a service, provided by AWS. So you might be wondering why we didn't use that. At the time, we were doing comparison between Cloud Custodian and a service in AWS, and the findings shocked us. Clickbait. No, really, it came down to Cloud Custodian being more powerful, which, they were providing more granular filters and actions, so we could drill down to the very individual configurations of each resource. We could check the values, we could do data transforms on the value, so we could, looking at a tag, we could kind of transform the tag value within the tool, which seemed quite powerful, and multiple different actions, so, deleting the resource, modifying it, or, notifying someone else. It seemed like there was a lot of capabilities here, so that felt pretty good to us. Bit of a surprise, it supported more services within AWS. This isn't a dig at AWS because without them I wouldn't have a job, but yeah, an open source tool had more support than the AWS provided one. At the time, it's definitely changed over time. This was over a year ago. There was also more kind of options within each resource. So although AWS Config might have supported a resource, it might have been only limited to like 3 configurations out of the 10 that it could have had, for example. So it didn't feel quite complete. The other thing is it's multi-cloud. So at the time we weren't multi-cloud, but if we were, this is good scalability, gives us the option to move into other clouds like Azure or GCP if we wanted to. So it just felt like a nice wrapper package over everything in the cloud. It came with a bunch of scripts and tools that we could use for kind of related purposes, like generating documentation, for example. And if we wanted to, it acts as a wrapper for AWS Config anyway. So if we wanted an AWS Config rule, we could have just created it with Cloud Custodian. So it felt pretty complete to us. The downsides, C7N is a numeronym. I don't know if anyone's heard of this, but this was the first time I kind of discovered it. All those kind of weird acronyms with the numbers in between, like I18N and K at S. What the hell is K at S? Now, for the longest time, I saw K at S, and I had no clue what it was. And so I just ignored it, and then I realized that's Kubernetes. Numeronym is basically an acronym where you take the first letter of the word, and then the last letter of the word, and then whatever letters in between are left over, it's like shortened to a number. And I hate acronyms, and anyone who knows me knows that I'm passionate about hating acronyms. So this is like a step up. This is like a big, big giant kind of, I don't know what I'm saying, but you understand. You understand. I hate numeronyms. They're really like exclusive. It's just difficult to figure out what they are. That's my main gripe with Cloud Custodian. So if that's the biggest thing that I found wrong, it's pretty good job then. This isn't really a limitation with Cloud Custodian, but more so just with general tools. AWS has this thing called CloudTrail. Said that like it was, CloudTrail. And it's basically just an audit log of all of the actions that happen within AWS. So every service has an API internally, and CloudTrail tracks all of those API calls and gives you, more information about like who called that, when it happened, all that kind of stuff. So it's basically just a central audit log for AWS. The thing with CloudTrail is that for some reason it doesn't like show every single resource and action. It shows the majority, but there's some actions that aren't actually recorded in CloudTrail. So if you rely on this fully for 100% of everything, you're going to find there might be some cases where configurations were missed because they weren't recorded in CloudTrail. The other thing is there's a delay of up to like 15 minutes or something, but I mean you can't really get much better than that. So it's not insanely real time, but it's as real time as AWS supports. Yeah, and it just basically works on having filters. So like you look for a certain config, and when that policy is matched with that config, then you run actions over it. So you like delete the resource or modify it, spawn other resources. So it seemed quite straightforward and quite like easy to read and kind of easy to transport between repositories and between teams. It felt like people who weren't super technical could write these policies. I was wrong about that because there's a lot of bugs and it is actually quite technical. But on the onset, it looks pretty simple. For our resource inventory, we used New Relic. No particular reason, it was just the tool that we were using at the time and we had access to. So we kind of had this summary dashboard and then details dashboard. Summary dashboard just showed like compliance overall, or like totals of categories of things, things that people invested in the overall project would want to look at. And then I also used a spreadsheet, Google Sheets. I'll talk about this a bit more later, but I highly don't recommend it when you're storing tens of thousands of rows in a online connected spreadsheet. It stops working. But that was like what we had access to. That was the easiest way to provide access to like product owners and developers and any stakeholders in the owners of the resource. We also use this thing called AWS Step Functions. So it's kind of like just our deployment pipeline, like running a bunch of cloud custodian stuff, processing that data, running a bunch of sub-actions to kind of saturate that data, and deploy it to like New Relic and then the spreadsheet. This is what we wanted on the left, and then this is what we ended up on the right. I don't know if I can complain, but this was the first time I'd done an architecture diagram, okay, so don't judge. I try to make it as readable as possible, but there's a lot of moving parts. We had a pipeline to deploy the pipeline, and a developer would do a pull request into the repo, and deploy a policy, and then the policy's, tested, and documentation is automatically generated, and it does, canary releases, and it does all these things that everyone should do when deploying stuff. But something happened, and that made it sound real bad. Just something happened, and like another team wanted to take control of it. And so we kind of ended up handing that over to them. So they maintained the deployment and the management of Cloud Custodian. So that was good for us because we just provided them the policies. To be honest, I don't know what they did with those policies. Tested it and just integrated it into the environment. And then we ended up with our compliance. So that was cool. Yeah, so this is the project I was talking about that I worked on for a year. Enforcing encryption at rest. Please don't judge me. There's a difference between doing stuff to be secure and doing stuff to be compliant. This was a compliance exercise. Basically, we had a need to ensure data at rest was encrypted, and it wasn't enforced like it was. It was enforced, but it wasn't enforced. There was S3 resources and EC2, so EBS. EBS is just like I said, the data volume of the instance. And there's about 30,000 of these resources. So pretty big scale that we're working at here, especially when it's like the first time we're kind of building this up. So the solution for that was our build pipeline, where the first box we kind of run the inventory, so we get an idea of everything that's in our environment, what resources aren't secure, or rather, what resources aren't compliant with certain configurations. We store that data in an S3 bucket, and then we process that data. So, we add tags, we add owners to the resources, a bunch of stuff that like makes it useful, basically. And then we send the results to New Relic and to Google Spreadsheets. This ran about every 2 hours, so it's just arbitrary time. I don't know, like a good balance between real time and not being super expensive. I won't run through the entire policy, I don't have enough time, but basically, this is an example of a Cloud Custodian policy, and in the end, all it does is it looks for S3 buckets that were just deployed in CloudTrail. There's an action you can look for, and if the encryption configuration of that bucket doesn't match a very specific encryption configuration, we delete it, and then we just send a message to the owner in Slack. This was the thing I was talking about, prevention, so technically it's not really part of continuous assurance, but it helps towards it. So this isn't linting, but basically if you have the ability to provide secure defaults or compliant defaults, you should do that because it makes everyone's job a lot easier. The developer finds out a lot sooner before this kind of stuff starts happening. So in EC2, we had this setting called default encryption, and basically you just set that on the account, on all hundreds of accounts. And every time a new EC2 instance is created, it's automatically encrypted. So that just makes the job a lot easier for new resources. So Cloud Custodian has a bunch of different kind of deployment modes. You can put it in the cloud so it runs on a cron job, or it can run when it's triggered by a certain rule or certain action in CloudTrail. But you can also run them manually in your terminal, so like on your computer or in a container, an ECS or something like that. So this was just an on-demand policy we created just to set the configuration on the account. So we just do it once, and then once it's set, it's done. This isn't related to continuous assurance, but this was a weird thing we found. With S3 buckets, when you turn on default encryption, it turns on the setting to encrypt new objects that get put in the bucket, but it doesn't touch any of the existing objects. So we found that there were a lot of S3 buckets that had existing data, and we turned on this the setting to make it encrypted for new resources, cool. But there was nothing that was encrypting the existing resources in that bucket. So we created a tool to basically run through every S3 bucket, take the object out, put it back in once the default encryption setting was back there, and then it, automatically encrypts it. Yeah, so some challenges. Hopefully you get something out of this, because I wish I kind of knew these things before I started. With Cloud Custodian, it's an open source tool, so it's great, but with most open source tools, there's kind of bugs, there's undocumented stuff, the documentation isn't always accurate or easy to understand. Most of it was really good, and I picked it up pretty quickly, but there's just edge cases and corner cases that just kind of catch you. So there's a lot of troubleshooting and resource configuration caching. So when you run the tool locally on your laptop, it scans the resources in your account, and then it stores that information, it caches it in a directory on your laptop. But from what I could see, that wasn't documented anywhere. So when I was developing these policies and changing a resource in real time in AWS, I was trying to figure out, why are my resources not responding to this policy? And it's because every time I'd change the resource in the cloud, it wasn't being updated in my cache on my laptop. So I found a lot of time I was just wasting. So there's a directory where they store the cache, and if you use Cloud Custodian, delete the cache when you're developing policies. No concurrency, so in a policy you can have multiple different policies, so that didn't make sense. And like in a policy file, like a YAML file, you can have multiple groups of policies. If you run that policy file, all of those policies are run synchronously, so they run one after the other in series. So there's no parallelism, there's no optimization, if you end up with like pretty expensive policies, it can get quite slow. And I'll talk about that in the next one. Resource inventory, so we use this for the resource inventory, but it's not really built for it. We kind of just used it because we'd already set it up and we were used to it. Basically, we had to set up an individual policy per permutation of a resource. So one resource was described in one resource configuration was described in one policy, and you change the resource a tiny bit, like you change a tag or you change the encryption configuration, and it's a whole new policy. So instead of one policy to kind of look at everything, it's multiple policies to check on every single iteration of a possible resource. So we ended up with about 30 policies just to look at S3 buckets, EBS volumes, and EBS snapshots. They're just like backups of EBS volumes. So very, very quickly got out of hand. And this is just for looking at one thing, looking at encryption for a resource, for 3 resources. We ended up with 30 policies. So don't use this for resource inventory. Go with another tool like AWS Config or other tools that are designed to give you a full picture of your environment in an easy way. With Google Sheets, yeah, so we ended up chucking in about 40,000 rows, which was very slow, and at times it just crashed. I'd put updates in the spreadsheet and it would just drop it sometimes. When sending new data to Google Sheets, the requests pretty often timed out, so I have to have a lot of retries. And with New Relic, the only thing really we found was that queries are somewhat limited, probably just for user experience. I don't want to get it too complicated, but I found I was wanting to do a lot with the data to display to people, transform the data in a way that it was valuable to non-technical people. But you really have to process that data before you put it in New Relic, because New Relic doesn't really give you a lot of those tools. This was the main thing that we faced with the project. Basically, a lot of teams that kind of get get created to kind of run a project, build a product, whatever, and then you kind of move on to the next one. And there's no real set definition. There is now, but back in the day there wasn't, of like who should maintain those resources, who owns them, who's responsible for them. And so we had to solve this piece before we ended up going with the, we're modifying your resources, can you help us out? Because more times than not, we would find there was no one owning this resource. And we weren't just going to modify it on behalf of someone or delete it because we don't know what it does, we don't know what it's connected to. It's the whole, no one wants to touch the old instance server running something because it might break. So that took a long time for us to fix. And it was a little political, just with, it was really difficult to get buy-in and movement and traction with this project. We had this project because we had a compliance need. We needed to, do something by a certain date. So it was very important. The business definitely needed to do it, but without the right investment at the leadership level, coming down to the developers and kind of reprioritizing things, it was very difficult to get engagement. And the old Swedish handoff, that's a term I've coined myself. Basically, we got given the project with like 6 months to do it. We're just out of the blue, and it'd been known about for a while. So that was a little frustrating in the fact that we didn't have a lot of time to do this in the best way we wanted to do it. We kind of have to just get the project out, MVP. We couldn't do all the beautiful things I said at the beginning that I hope everyone else does. So it was a bit rushed. And yeah, when everything's a priority, nothing is. And that's definitely what we found with our project. So summary, I think continuous assurance is very important, and I think everyone should be doing it. It's definitely one of the best solutions to insecure infrastructure. There's obviously a lot more that you need to do, like patching and a bunch of other stuff, but this provides a really good way to automate it and to scale. Just part of well-managed cloud, part of your responsibility as the customer in AWS to make sure that your stuff is secure. It's a huge burden, and without the right tools, it's very difficult to do, and it very, very quickly gets complicated. So this does a really good job of kind of doing it for you. Once it's set up, you're good. Makes auditing a lot easier, and choose your tools wisely because don't use a spreadsheet. And then just enterprise issues. When you've got a company of 4,000 people, 5,000 people, implementing this type of thing in an existing environment is extremely difficult. So I urge anyone who's looking at this to do it as quick as possible, as early on in your cloud journey. Do this from the very get-go, so you don't have to mess around with ownership issues or doing stuff when it's already been deployed in production. That's very difficult to figure out. And this is the first time I've spoken at a conference, so I'd appreciate any feedback. If you could, let me know how it goes, that would be really cool. And you can talk to me on LinkedIn. I kind of had to cut out a bunch of content, the technical stuff, to fit it into 30 minutes. So if you have questions about very specific technical things, I'm happy to answer them. And last thing, ZX Security is hiring. So we're looking for any consultant from a junior to a lead in our pen testing, cloud, and our risk and compliance kind of divisions of the company. So if this type of thing interests you, come have a chat to me or anyone else in ZX. And we've got a lot of exciting projects like this type of thing lined up for ZX Cloud. That's my talk.